Hello, welcome to another exciting change of subject series. In today's series, we would be solving a practical change of subject question. So in this series 16, the question for today is if, or in brackets, the fraction h plus I divided by h minus 1, that's all in brackets square, equals j, and 2l equals a, or in brackets I plus h, express l in terms of a and p. Now the preamble is giving us, or in brackets square, h plus I divided by h minus 1 equals j, right? So, or in brackets square, h plus I divided by h minus 1, we need to eliminate the square, right? And in order to eliminate the square, for the equation to stand on its own, right? These two, we need to eliminate it. The entire relation, which is the base, has an exponent or a power, which is 2. So the entire base, which is the equation here, is multiplied. So the entire base, which is h plus I divided by h minus 1, is equated to the power or the exponent 2, which means that divided by a minus 1, right, is how many times 10 that this factor is multiplied by itself. So this factor is multiplied by itself times 2. So in order to eliminate it, you have to find the square root. And when you find the square root, you apply it to both sides. One thing you have to notice is that in mathematics, what you do for the left side, you do same for the right side, right? So in order for us to eliminate the exponents, okay, so we have to eliminate the exponents. So in order for us to eliminate the exponents, we have to find the square root and apply that principle to each side of the equations. So eliminate the exponents, right? So we have to eliminate the exponent. So let's eliminate the exponent. So in doing so, have to find the square root and apply it at both sides of the equation. So the entire equation will be square root of, or in brackets square, h plus I divided by h minus 1 equals square root of j, right? So the square root, right, would cancel out this 2, okay, for the equation to stand on its own. So we are going to have h plus I divided by a minus 1 equals to the square root of j, right? So in doing so, we have to cross multiply, okay? We have to cross multiply. So we have to cross multiply, right? And this j, the square root of j, has an invisible one, right? So h plus I divided by a minus 1 is equal to j the square root of j divided by 1. So 1 times h plus I will give you h plus I. A minus 1 multiplying square root of j will give you square root of j multiplying a minus 1, and we equate it as equation 1. Also, based on the preamble of the question, we are given another equation as 2l equals a, or in brackets, multiplying or in bracket I plus h, right? So in order to break it down into its simplest form, for L to be the subject of the relation, right, you have to cancel it out by the LCM. Okay, so you cancel it out by the LCM, and based on the nature of the equation, the LCM is 2, right? Because that's the only number, the least common factor that can divide through for L to be independent. So when you divide through by L, right, this 2 will cancel itself, and it will cancel this 2 on top on the numerator, and we are going to have L equals the fraction a multiplying I plus h, or in bracket, divided by 2. Therefore, L equals the fraction a multiplying I plus h divided by 2, and we would equate that as equation 2, right? So this equation 2, we are going to find L from it, right? So based on our equation 1, we were able to come to the conclusion that I plus h is the square root of j multiplying a minus 1. Okay, so hence we put this equation 1 into equation 2 in order to find L. Okay, so hence put equation 1 into equation 2. So therefore we are going to have, remember equation 2 is L equals a multiplying I plus h, right, divided by 2, where I plus h is equal to the square root of j multiplying a minus 1. So our L is going to be a multiplying the square root of j times a minus 1 over 2. So that's our final answer. So thank you so much for watching this video. Kindly do well to subscribe for more. Thank you. Bye.